Good afternoon. We start the fourth lecture, and today we're going to look at beans, scopes and attributes, which is going to help us set up the environment whereby we can have the model elements of our architecture communicate with the view, passing data from the model to the view via these attributes and beans in the various scopes. So we'll look at what the Java bean is, we'll learn about scopes in internet applications, and we'll also look to see how to use the attributes in the various scopes. So Java beans. According to the online material, a Java bean is a component that is reusable. It's just an ordinary piece of software that follows a simple naming convention and therefore presents a standard interface to other beans programs and tools. And it is really very simple. There's a set of minimum requirements and a set of optional requirements. And so as far as Java is concerned, a Java bean is a Java class, just an ordinary plain old Java class that complies with the Java bean component model. And for it to comply, it must have a public, it must be a public class. It must have a constructor with no parameters, in other words, a default constructor. And it must also implement the java.io.serializable interface. And in implementing that interface, it can then be saved to file, it can be sent down data streams and so on. For example, it could be written from a server to a client because it can be serializable. So those are fairly limited but essential minimum requirements for a class to be termed a Java bean. Some optional features, well, a Java bean will usually have properties. In other words, some variables in which to store data. And for each of those properties, you might have one or both of the following: an accessor method, a get method, or a mutator method, a set method. And these methods, as you're well aware, will permit the client of this class to get or change data values for those properties. It's also possible to have various listeners registered and deregistered with these beans, and that can therefore set up the requirement to have certain callback methods to be implemented in them. But as it says at the top of the screen here, these are optional features. So for us to call it a Java bean, it must be a public class, it must have the default constructor method, and it must implement the serializable interface. And so here we have a very simple bean example. In the header for the class, we can see that it's called myBean. This is the important thing: implements java.io.serializable. And simply implementing that interface means that that bean, objects of this bean, can now be deconstructed for saving or writing in some way or another. Saving to file, writing down data streams, and so on. And when it gets to the other end, because it's serializable, having been deconstructed and sent down the line, it will then automatically be reconstructed by the Java virtual machine. In this very simple example, we've got just one property called name of type string. It could be private or some other kind of visibility set to it. Here's the default constructor. Now a constructor method has as its job to initialize the variables that are within that object. So here we're just setting up name to be just something fairly arbitrary. And then in this example, we've got a get and a set method for this property. But you don't have to have both. You might perhaps have just a get. But if you've not got any mechanism in here for setting the value for that name to something meaningful, then it might not make much sense to omit set name. So usually with a default constructor which is giving default values, you probably would want a set method as well. And that's basically all there is to Java beans. Not very much at all. But they will be very useful for us later on. Now, a scope essentially defines the visibility or accessibility of various components. And anything that is added to a scope is then only available within that scope. So a scope has some very well-defined boundaries. Anything that is inside the boundary is available within that boundary. Anything that is outside of that boundary is not available from within that boundary. More detail of that in a little while. Now with Java servlets, we've got three types of scope: request, session, and application. The request scope typically is of a very short duration because it starts when the request from the client arrives at the server, and it will end when the servlets have finished processing that request. And therefore, typically, it will last for just a few milliseconds. Only servlets that are processing that request can access it. And we gain access to the request scope by using the request parameter that is passed in to the doGet or the doPost methods. So that parameter that we've been using up until now, the request parameter, is more than just here is some information about the request itself, but it is also embodying the request scope. The session scope is of longer duration because it starts when the first request from a given client arrives at the server, and it will end in one of two ways. Either programmatically a servlet will kill the scope, or that scope will time out after a certain period following the last request from that client. So a session scope exists for a given client. So we might have a web browser that sends in a request. That first request will create the session scope. If that web browser sends in more requests within the timeout period, then that will keep the session scope alive and will reset the timeout counter. Let's say there's a request come in, it's request number 20 or whatever, and the user then leaves their workstation, goes and has a break of some sort, and does not come back to work on that client within the timeout period. That timeout period then expires. The session will automatically die because the server will be managing these scopes, and when the timeout expires, the server will delete the session scope. When the user comes back to the workstation, the user, of course, has absolutely no concept at all of what's happened over on the server. And therefore, perhaps we'll just resume where they left off and send in another request. That request will still be processed, but it has now, because the session that this client was with has expired, that request will now essentially start a new session. Or maybe, depending on how the application is set up, maybe what will happen is a message will then come back to say your session has expired. And so maybe the user has to log in again or something like that. Servlets that are processing any request from the same client within that session will be able to access the session scope, and they get to it via the request. Request.getSession will provide a reference to that session scope object. The application scope is very long. It could be weeks and weeks and weeks in duration, because when the internet application is deployed to the server, then the application scope begins. And if the application remains active on the server for weeks and weeks and weeks, then so does the application scope. And what will terminate the application scope is the removal of the internet application from the server. Any servlet that belongs to the internet application that is processing any request from any session, from any client, that servlet will then be able to access the application scope. And access is obtained by calling from within the servlet this.getServletContext. So I mentioned earlier on about boundaries. Scopes have very well-defined boundaries. The requests are isolated from each other. In other words, while processing a request, let's call it request A servlet is not able to access any other request scope. And of course that makes sense, because the parameter that arrives on the method call is the scope. And so while that method is executing for a given thread or process, then it has only got access to that one request object, and therefore is not able to get hold of other request objects. Sessions are isolated from each other. So if a servlet is processing a request for session A from client A, then it will not be able to access the session scope for client B. And this is because we access the session via the request. And the servlet container will have already automatically sorted out which session the request belongs to, and will have stored the reference to that session scope within the request scope. And therefore, when we call request.getSession, it will give us reference to the proper session. Now there's only one application scope per application, and therefore there is a very big boundary. It includes all sessions from all clients and all requests within that session. The thing that to bear in mind, of course, though, is that this servlet that we might be looking at any one time is able to gain access to the application scope for the application to which it belongs, but it cannot get access to any other application scope, and therefore applications are isolated from each other on the server. Here's an illustration of scope duration. We have time dragging on from left to right, and we're assuming that the application remains active for the entirety of that time. So the application scope exists throughout the time period. So client number 1 sends in a request 1.1. And the arrival of that request will start the session number 1. A little bit later, client 2 sends in a request 2.1. That creates another session. And because the session for client 1 has not yet timed out, that session still exists. But of course, servlets that are processing this request are able to get hold of this session, but are prevented from gaining access to session 1. A little bit later, client 3 sends in a request 3.1. That creates session 3. Because there has been no request from client 2, and it would seem that session 2 has got a very short timeout period, session 2 has now expired. Therefore, that session no longer exists. Also, and just a little bit after client 3 sent in a request, client 1 also sent in a request 1.2, and that has prolonged the life of session 1 because the timeout counter is reset. Request 2 comes in from client number 3, so session 3 continues, but now session 1 has timed out because there's been no further request from the first client. So request 3 comes in from client 3. That has extended the session, but as is noted here, this particular request has now triggered the programmatic deletion of the third session. So this is an example of where the session has been programmatically terminated. In the meantime, a third request came in from client number 1. But because session 1 has timed out, a new session has been created. Now all this session management is essentially taken care of by the servlet container. We have some control over it because as it illustrates down here, a request or a servlet that's processing a request can delete a session. But that's about as much control as we have programmatically over a session scope. So let's now bring those two concepts together, Java beans and scopes. And the way we bring them together is by using these attributes. Attributes are used to store data, and we can associate an attribute with a given scope. And we do that by setting an attribute, which will then create the attribute in the nominated scope. We can then get access to that attribute by calling the get method. We'll look at that in detail in a moment. And we can remove the scope, the attribute from the scope by calling the associated remove method. Now, these attributes are used to store data. Objects, such as Java beans, are able to store data as well. And so if we were going to set an attribute, we would first need to set up an object. Could be a Java bean object, might be some other kind of object, example coming up later on. And having got this object ready to be put into the scope, we can then call from the request object .set attribute, and we specify two parameters. The first is a string, which is the name by which this attribute is going to be known within the scope, and then the reference to the object that is going to be the attribute. Now, this is for the request. Of course, if we're going to do this for a session, then we have a slightly different reference here. If we now want to get this attribute that has been set, then we call request.getAttribute and pass in as the parameter a string with exactly the same name as was used for setting the attribute. Now, the thing to bear in mind here is this object could be of absolutely any type. It could be a string. It could be an array list. It could be one of our own Java beans. And therefore, because it could be of absolutely any type, get attribute is simply going to return that reference as something of type object, because the object class sits at the top of all the inheritance hierarchies within Java. Therefore, this reference, obj, can refer to absolutely any type of object, an object of any class. And so that's how getAttribute returns the reference. So it might be that we have set, let's say, a string as an attribute called attriname. But when getAttribute works, it will look for attriname, find it, and return a reference to it as a reference of type object, not string. It's still a string object, but the reference to it is a reference of type object. And therefore, typically, what we would have to do is then to typecast that reference back into a string. We'll show an example of that a bit later. If we wish to remove the attribute from the scope, then we call from request the remove attribute method. And again, we must specify the name exactly as it was spelled when the attribute was set. Now, what we're going to do is to look at a couple of examples now to see how these things can be used. So in the Attribute Examples project, let's take a look first of all at the example 1 in the servlets. We've got a model, control and view. Take a look at the controller first of all. We're using, well, we're not expecting any problems here, so we haven't got any try-catch blocks or anything like that. But the basic process is this. We're going to dispatch the request to the model component, and then we're going to dispatch the request to the view component. So something really, really simple. Because what we want to focus on is the mechanism of communication between the model and the view. So let's go and look at the model first of all. In the model, what we're getting from the request are these two parameter values, and then a little bit of validation. If there was no first name parameter, then we are going to set our variable first name to be just the empty string. Likewise for last name. If that wasn't there, then we're going to set it equal to the empty string. And then we're going to create a new variable called full name that is the combination of first name followed by a space followed by last name. So this is a very trivial, simple, almost nonsensical example. But it's going to illustrate the communication mechanism between model and view. And the way that happens is this. When the model has produced the data that the view needs, it's going to set it as an attribute. And so the variable full name becomes the second parameter in the setAttribute method. And we have decided that the name that we want this attribute to be called is full name. We can use any name that we want, any string that we want. But of course it should be meaningful to help us, the programmer, and the other programmers who might come along to maintain this code at some point in the future, to help us all to get an understanding of what this attribute should be. So that's the first part of the mechanism. The model has generated some data. Now, of course, this could be that the model has communicated with a database, extracted some data, and put that data into a Java bean. And then the Java bean will be set as the attribute. That's going to be one of the other examples we look at later on. But for now, instead of using a Java bean, we've simply used a string and put that string as an attribute into the request scope. And it's important that we remember which scope it's gone into, because since each scope is isolated from all the other scopes, if we put it into one scope, then we're going to have to go back to the same scope to retrieve it. So having activated the model, and the model has set up the attribute, control comes back to the controller, and you'll notice that the controller does absolutely nothing with this this particular attribute. And so it simply activates the view component. And what the view component does in this statement is to call from the same scope request the getAttribute method and passes in as the parameter the same attribute name that was used to set the attribute. Now remember, getAttribute, if we take a quick look at the drop-down list by hitting Control Space and then narrow the list down a little bit, the getAttribute method returns a reference of type object. Now we know that this attribute is of type string, and therefore we typecast the reference from a reference of type object to a reference of type string, which then allows us to store that reference in this variable of type string. And then we can use that as an ordinary string object, which is then used lower down in the code here. So that's how we have the model set an attribute in the request scope and then retrieve it in the view from the request scope. And the other examples that are in this particular project, example 2 and example 3, do exactly the same thing, except that example 2 uses the session scope and example 3 uses the application scope. Let's take a look at a slightly more involved example. Let's close down all of those windows, and now we're going to take a look at this example, the beans example. We've got a number of servlets here. The controller, we've got 3 model components: get the table, delete a row, insert a row. Remember when we talked about MVC in the previous lecture, we said that each model component should limit itself to one act of functionality. Insert is one act of functionality, delete is another, get is a third. And by separating these concerns, we now have, we've multiplied the number of servlets that we've got in the system, but on the other hand, we've now got something that is very flexible, because we could have several requests that as we process those requests, we might need to get the department table. But if we've built that into some other kind of functionality, then we're going to have to start duplicating code, which is not what we want. So we separate it into its own little model component so that we can call it as often as we need. And there are 2 view components, one where there's no problems and the other where there is problems, and we've got to report the error. For the getDepTable component, to generate data, it's going to have to communicate with the database. The view will need to display that data, and so we're going to use the dept Java bean as the communication mechanism. So getDepTable will generate one or more of these objects, and the view will retrieve them from the scope that getDepTable set it into, and then we'll display the data in some way or another. The way the view displays it is view dependent. So here we have yet another example of separation of concerns. It doesn't matter whether this is an HTML view, an XML view, some other kind of view. It really doesn't matter. The generation of the data and the storage of that data as an attribute does not change depending upon the view. It's only the view that changes. And so the view will then display it in a way that is appropriate for its client. We could also have two different views. Let's say both are HTML views. For the same piece of data, we could traverse that data and in one view expose all the data in the view. And yet in a different view with exactly the same data we might expose a summary. So one of the very good reasons for separating view from model is so that we've got this total control and total flexibility about generation of data and display of data. Let's take a look at some of the detail here. Start off in the HTML here. We've got a form. It's going to send in a request to Bean's example, and it's passing in two parameters, one called uname and the other called pword. These are values that are provided by the user and are going to become the username and password for connecting to the database. So when that is submitted, the controller will pick that up and will then dispatch. Well, since the first thing it will do is try to get hold of a command parameter, but back here there was no parameter called command. Therefore, command is going to be null. Therefore, that line will generate a false for the Boolean expression, and so the if is not done. And therefore what the controller does is immediately call getDepTable. So let's take a look at getDepTable. The username and password are retrieved from the request, and they are then used along with the URL for the database to set up a connection to the database, and we saw how that worked in a previous lecture. This URL is valid if you're wanting to use the student Oracle database on campus. Otherwise, you're going to have to change that, as we discussed in a previous lecture, to make use of, let's say, the JavaDB database that ships with NetBeans. We're also, because we're going to be retrieving rows from a table, we're going to need an array list to store the data from those rows. And that array list is going to become the attribute that this model is going to set up for the view to consume. So for us to do that, we're going to need to take a look at this Java bean. The dept.java class tells us about it. We've got three properties: dept, no, dname, and lock. If you're familiar with Oracle at all, then you'll recognize those column names from the default dept table that comes with just about every installation of Oracle. Now, because this is going to be classed as a Java bean, we need to have a default constructor. It needs to be a public class, and it should implement the java.io.serializable interface. And it doesn't in this example. Therefore, this is not a Java bean, even though we might have put it into a package called beans, and that is really a bit of a problem. So what we'll need to do is to put in here implement, I could type it, implements java.io.serializable. And that now becomes a bean, because we've satisfied all three of the minimum requirements. Because this is a default constructor where we will just set these three string variables to the empty string, then we have set and get methods for each one of those. And that's the bean. So nothing terribly complicated. So back here in the getDept table servlet, we have now got an array list that will hold dept objects. We're calling it list, and it's initialized to just be a new list. Then we set up the connection. Here's the SQL string, the SQL command that we want. Select star from dept. We're going to create a statement, and because this is a select statement, we will execute query. And that is going to return a result set object. While this result set object returns true when next is called, in other words, while we still have rows from the result set to process, then for each row we will create a new dept object and then populate each of the properties within that object by using whatever rs.getString returns. So set dept no using the data in the dept no column from the result set, and so on for the dname and lock. Having populated the bean with all the data from that result set row, we then add the bean to the array list. So the first row is encapsulated in that bean and is then added to the list. Then next time around, if there's a second row, that will then be encapsulated in a new object and added to the list. Third row in a third object, added to the list, and so on. Eventually, there will be no further rows to process, and so the while loop terminates, and the only thing left to do is to take that array list object, which now contains references to all these dept objects containing the data from the database, and set it as an attribute called dept table on the request scope. Then, of course, we need to close the result set, close the statement, and that's the end of the model component. So what we've just seen is a mechanism for extracting from a database the data related to a particular request, put it into some bean objects, which are then encapsulated within a single array list object, and then put that array list object as the attribute, the one attribute in the scope. We could have many more than just one attribute on the scope. There's no limit. But here we're just using a single array list object that holds all the row objects. So that's the model. So let's come back now to the controller. The next thing it does is to activate the view. So let's take a look at view. This is a servlet, and what it does on line 21 is to get from the request scope the attribute called dept table, which of course is the name that was given when the model set the attribute. Then, because get attribute returns the reference to this array list as a reference of type object, then we are going to have to do the typecast. Sorry, didn't quite get it right there. There we go. The array list dept is the type for this object. We're doing the typecast so that we can now store it in the local variable here called list. Now, of course, things can go wrong, and therefore we really ought to test to see if list is equal to null, because if it is, that's a problem. We were expecting the list to exist, even if it was an empty list. You can have a list object with no row data in there because the table was empty. That's legitimate. But to have no list object at all, that's a problem. And therefore we would throw a new servlet exception with the message to indicate what the problem is. But if list is not null, then the if doesn't happen, and so we can then iterate through the array list. And in this example, we're simply just setting up an iterator that is going to iterate through the list, of course. So here's the view. This is what we're doing. Set up the header information for the message back to the web browser, and we're outputting how many rows were affected. Then that's not relevant really for a selection. We'll see more of that later on in this example. And then we're going to iterate, and for each time we iterate, we're outputting an HTML row to go in that HTML table. Let's take a quick look now at what happens when this button, which is part of the rest of the view, there are two buttons that are going to be displayed on the web browser, one for insert and one for delete. The one for insert is going to cause the controller, because there will be a command on there, parameter, let me show you how that gets there. You see how the name of this button is called command in both cases, but it's got a different value. The user's only going to click on one of these buttons, and that will submit. So whichever button has been clicked will be able then to determine by looking at the command value whether it's an insert or a delete, and therefore know which of the other model components to activate. I'll show you the insert, and you can look at the delete in your own time. So the insert will get the request parameter, uname and pword for connecting to the database. It's going to insert. In this case, it's going to insert hard-coded values. So it's going to always insert the same thing. And then do the update. And then on the request scope, it's going to set an attribute called rows affected to say how many rows were inserted. Then, having done that, the controller is going to activate the getDept table model again to extract all the data from the table and then activate the view. And so the view will now be able, as well as getting the list, it will now find that this attribute, rows affected, exists. And therefore it will be able to report how many rows were affected, as well as show the current contents of the database table. And so you get to see there the flexibility of having individual model components with one area of functionality per model component. Okay, so take the time to review this code, download it, execute it, see how it works, and if you have any problems, then get in touch and ask your questions. And that is all for today. Thanks very much.